Okay, so we're going to be beginning chapter 14 from our book, but in your math lab it actually is chapter 13. So when you are doing your homework, you'll do chapter 13 homework just like it's listed on My Labs Plus, but in our book it's actually chapter 14, and I don't know why the sections are off, but we're gonna do the notes of chapter 14. We'll do chapter 13 notes in our last chapter. That'll be our last chapter that we do, and hopefully we'll be able to get through everything without too much confusion. Again, chapter 14 from the book, so that's what you're going to see here. Chapter 13 though in the math lab, so just kind of be aware of that as you're working. Follow the modules, follow the math lab section, due dates. You should have all that correct. This though came from chapter 14 in the book, not 13. So we're going to start by talking about different transformations. And you may be familiar with transformations. If you took a geometry class in high school, you probably learned about transformations a little bit. And so we're going to talk today about a few different types, and probably we'll break this up into 2 or 3 different videos, kind of focusing on each type. So the first thing we need to know is what we mean by isometries. Okay, this is any rigid motion that preserves length or distance. Okay, so there's going to be a couple that we're going to talk about. A translation is going to be the first type. Basically, a translation, and we'll talk more about this in a second, is basically a sliding of one figure to another location. Okay, so you're going to see that. Any function from a plane to itself that is a one-to-one correspondence is what we call a transformation of that plane. So again, these transformations we're going to look at, there's going to be translations, there's going to be rotations, there's going to be several others. We'll talk about tessellations in this section as well. And so because these transformations are functions, they're going to have properties of functions. So all the properties of functions that you learn about in college algebra, for example, they're all going to apply here to these transformations. And we won't get into that in much detail, but just kind of be aware that we are dealing with functions here as far as how these things move. Okay? So a translation is basically a slide from one place to another. So if you look at this diagram here to the right, it is simply that idea. You start at the top of the slide. When you slide to the bottom, you still are the same person, same shape, same size. You're just now in a different location. And you slid in one direction, in this case down the slide, and you can see that reflection. So you see the original is the boy sitting at the top of the slide. The slide image, or the new image, is there at the bottom of the slide. Okay, and so when we talk about this idea of a translation, it is literally that, taking a figure from one point on the coordinate plane and shifting it or sliding it to another place. You might slide it right or left, or you might slide it up or down. You could slide it a number of different ways, but that's all it is. Every point in a translation of the original figure moves the same distance in the image. Okay, and the image after you have slid it, every point is moving the same distance in a straight line. Okay, so that's important to understand. It's not that one point moves one distance and then another point moves a different distance. They're all moving the same distance in the same direction. So a figure and its image are congruent. Same shape, same size, right? Again, the boy sliding down the slide, he doesn't change shape or size from the top to the bottom. He's still the same shape and the same size. And then notice that the image of a line is a line parallel to it. In other words, if you were to take a line and you were to, let's say, let's say you were to take this line here, we'll call it line D. If you were to shift it or slide it, let's say this direction. Well, when you draw that new line, because every point moved the same distance, that new line or that image is going to be parallel to the original. Okay, so that's what that says. If you slide a line one direction or the other, it is the new line, the image is parallel to the original. So a couple things here. Notice that we're calling the first image the original. We're calling the next one the image. Okay, so just be aware of that. You'll see that as we go through some of these examples. Alright, so let's look at example number 1. It says to find the image of segment AB under the translation from X to X prime, pictured on the dot paper. So in other words, we want to take this and we want to move line AB in the same direction that we move from point X to point X prime. Okay? So think about, how does X move from where it is currently to X prime? Well, if you'll notice, it goes down 2 units and then goes right 2 units. So by that same logic, if we were to take point A and move it down 2 units and then move it right 2 units, then point A prime should be here. And again, because every point moves in the same distance, the same direction, point B should do the same thing. So you move it down 2 units and then right 2 units. And so this point should be B prime. And so there would be our new segment. And so we have just shifted the whole thing down 2 and right 2 along this line. Okay, this line that was given to us. And you can see, as we put in the drawing there, you can see what's happening. Again, we've just shifted it, just slid it to its new position. And this statement here at the left says exactly what we did. We moved down 2 units and right 2 units. Okay. If you have any questions about how to slide that, let me know. Hopefully that's not too terribly difficult for you. But if it is, feel free to let me know. We'll try to clear up any confusion. So look at this. When we talk about these translations, we are moving, if you think about sliding the original to its image, you can think about taking each vertex of your figure, whatever that figure may be, if it's a triangle or a cube or whatever it is. Okay, you can, it wouldn't be a cube, it'd be a square. You could slide it and think about, okay, how much does each vertex move? Because it's a little difficult to take just some random point and say, okay, I need to move this point to here. Well, that's a little more difficult for us. But we can take point A, for example, and see, okay, well, how do I move it to point A prime? Or I can take point B, and how do I move it to B prime? And so on. And so when we talk about this translation, we're going to think about moving each vertex. So, if you look at point O, this point here at the origin, if we're going to move an image along the line from point O to, we'll call this O prime, if we're going to move it along this line, we need to think about, well, how do I move point O to point O prime? Well, I would move right 1, 2, 3, 4, 5 units and down 2 units. And so that new order pair is 5, -2. So if I take that 5, -2 and I add 5 to each x coordinate and I subtract 2 from each y coordinate, then I should be able to move each vertex the same distance. And you'll notice here that's what's happened. You take point A and you move 1, 2, 3, 4, 5 units and then down 1, 2 to get to A prime, or get to the new A. And same thing with B, you move right 5 and down 2. And same thing with C, right 5 and down 2. And when you do, you've slid that whole triangle down and to the right. Specifically, 5 units right and down 2 units. Okay? And so we can represent that in this table where we say, okay, our original point is XY. Our image point is going to be X plus 5, Y minus 2, whatever that order pair is. And so if we know the order pairs for the original, then we can add 5 to the X and we can subtract 2 from the Y, and that's going to give us these new points for A prime, B prime, and C prime. Okay? So you can see how that shifted, right? You can see that shift. Go back, watch the shift here, shifting it down. For some reason that's a little bit off. It should be on that pink triangle, but you see the idea. It's just that idea of just sliding that down. So if we want to take a translation in the plane and we want to move every point from the original to the new point of the image, we need to figure out how much we're moving right and left and up and down. And then we're going to add or subtract the right and left value, and we're going to add or subtract the up and down value, and that should give us our new point. So we can write it symbolically like this. And we use this arrow to say the original point moves to the new point. Okay, so as we look at some of these and we talk about the original and the image, we're going to use that notation saying, okay, this point moves to a new point. So let's look at this one. It says find the coordinates of the image of the vertex of quadrilateral ABCD under the translation in parts A through C. So each slide here is going to have a different part. So we want to list the order pairs when we move this original image, this original square shape that you see, 2 units left and up 4 units. That's what it tells us. Moving 2 left or subtracting 2, and then moving up 4 units or adding 4 to that Y value. And so if you take point A, which is 0, 0, and we move it to the new point, well, we're going to subtract 2 from our X coordinate, so it'll be -2. We're going to add 4 to the Y coordinate, which will be +4. There's going to be our new point. That's going to be A prime. For point B, we're going to take 2, 2, and we're going to move it again where we subtract 2 from X and add 4 to Y. So we're going to have 0, 8. No, I'm sorry, 0, 6. I was looking at the wrong one. There we go. So again, subtracting 2 from 2, then adding 4 to the 2 to the Y value. So that's going to be B prime. And then point C is 4, 0. We're going to move it, again, subtract 2 from your X, so it's going to be 2 for the X coordinate. Add 4 to the Y, which will be 4 for the Y coordinate. And that is going to be point C prime. And then for point D, it's at 2, -2. And we're going to move it by adding, or by subtracting 2 from the X value, which is 0. And we're going to add 4 to the Y value. So 4 plus the -2 is just +2. And so now if you were to actually plot all these, and we'll do this in a few minutes, point A would be 1, 2, 3, 4. It'd be somewhere up there. Call it A prime. Point B, if you were to move it to 0, 6, well, there's 0, and then 4, 5. No, I'm sorry. That's 3, 4, 5, 6 would be somewhere up there. And you can see that that appears that we have shifted that part of it correctly, right? And then point C, we move it to 2, 4. So 2, 4 is going to be there. So we'll call that C prime. And then point D, we move it to 0, 2, which is here, which is D prime. And again, when you connect all those, you can see that you do have this same square. It's just been shifted over, left 2 units and up 4 units. Again, this is D prime. So if you have any questions about that one, again, let me know. Hopefully that won't be too much of a problem. Now, part B says that we want to take a translation determined by the slide arrow from 0 to -2. Well, again, think about what that means. If you have the origin and you slide this 2 units left and up 1, 2, 3, 4 along this line, well, we're just taking 0, 0 and moving it to -2, 4. Well, that's exactly what we just did in part A, right? And so the translation, we'll just say this as the answer, the translation is the same as part A. Because again, if we move that along that arrow where we move it left 2 and up 4, every point gets moved left 2 and up 4. And so left 2 and up 4, and left 2 and up 4. And so again, you see we have that similar rectangle. Okay. And then part C says that we want to find the translation determined by the slide arrow from 4, -3 to 2, 1. So let's think about what's happening to go from point S, which is 4, -3, to get to S prime, which is 2, 1. So the question is, what happens between your X coordinates, what happens between your Y coordinates? Well, the X coordinate, to go from 4 to 2, we're going to subtract 2. And for the Y coordinate, to go from -3 to +1, you'd have to add 4. Well, again, that's moving our X value left 2 and our Y value up 4. It's again moving it up here, right? Left 2, up 4. And that slide line is the same as, let's see if I can plot each of these points. So 4, -3 was here, and then 2, 1 is there. Well, again, if you notice, what are we doing? Well, from here, this is S, to S prime, we're going left 1. Nope, hang on, I got the wrong points here. So we had, I'm at 5, not 4. So this one's not right. So there's 4. Alright, so this is S. And so we're moving 1, 2 units left, and then 1, 2, 3, 4 units up. And so again, this slide line is the same as this one, or is it the same as the previous 2? And so again, we're going to say that the translation is the same as part A, and B for that matter. So here's what it should look like when you actually do that translation. You can see each point A to point A prime, move left 1, 2, and then 1, 2, 3, 4 up. Same thing with point B, 1, 2, then 1, 2, 3, 4 up. Same thing with C, 1, 2, 1, 2, 3, 4, and then same thing with D, 1, 2, 1, 2, 3, 4. And so each of those got moved left 2 and up 4 to get us to that point. If you have any questions about this example, let me know. I'll be glad to answer any questions you have. We'll continue talking about translations and rotations and tessellations in the following video.